Hello. So this video will be here to assist you in calculating a weight-based drug for a patient that you're taking care of, neonate, and we will use the example of ampicillin for this drug and for this video, and we will say that this patient that you're taking care of has sepsis. So we're going to start out with, first, we have a physician's order that says to give ampicillin. And they want to give 200 milligrams per kilogram per day, and they want that divided into 3 doses during the day. So, since we know we have a kilogram in this equation already, we need to know what the patient's weight is. And we're going to have the patient's weight be 2,900 grams. And we also need to know how is the facility going to provide this ampicillin to us. And the facility is going to give you 200 milligrams per ml ampicillin. Okay, so the first thing we need to know is how much drug will this patient be receiving today? So the first thing we're going to look at is going to be the amount of drug per day. So since we're referring to the drug, we have milligrams. And since we're referring to day, we have day. So I like to start out by finding out what is it that I'm solving for. So I'm going to solve for milligrams per day. Where do I find my milligrams per day? Right here in the physician's order. 200 milligrams per kilogram per day. So what I like to do to help simplify it for me, to make sure that I keep myself on track, is to identify that I've already solved for one of my descriptors here. And then here I already have day as well. So I have the 2 identifiers that I'm looking for. But I'm still left over with the kilogram. So I need to eliminate the kilogram from my equation in order to solve this equation. So kilogram then, I know that I have a patient who weighs 2,900 grams. Now I need to convert that grams. It's not grams that I want because I'm trying to eliminate the kilograms. So then I realize that I have 0.001 kilograms equals 1 gram. Now I can eliminate the kilograms, and now I can eliminate the grams, and I'm only left with what I'm looking for, the identifiers of milligram per day. And at this point, I can solve the equation, and my super quick brain says I have 580 milligrams is what this patient will receive per day. Okay, so this is per day, but the doctor's ordered for this drug to be given 3 times a day, or this much divided into 3 doses every 8 hours or 3 times a day. So now I need to decide how much drug per dose. Okay, again, I like to find out, well, what does that mean I'm solving for? For this, that means I'm solving for milligrams per dose. Okay, so I know that I have milligrams per day over here. So let's go ahead and bring that down. I have 580 milligrams per day. So I already have now my identifier for my numerator, but day is not what I want, dose is what I want. Well, I know that in 1 day, I give 3 doses. So you see how I already was able to cross out and eliminate the day. So now I have milligrams per doses. I have exactly what I want to solve for. And at this point then, again, using my super quick brain and my math, actually I just solved it out beforehand, as you already know, but it's 193.3 milligrams per dose. So 3 times a day, I will give 193.3 milligrams, and that will equate to the 580 milligrams per day that the physician has ordered. Okay? Well, now at this point, I need to decide, okay, well, how do I pull that out of the syringe? How do I pull that out of the vial that the pharmacy sent that to me? Well, so at this point I need to decide how many mLs per dose. So I found how much drug. Now I need to find out how much volume. And that's what mLs tells us volume, milligram tells us how much drug. So at this point, I know I'm given 193.3 milligrams, which is the drug amount, but how much volume am I going to pull out of this vial in order to give that appropriate dose? So mLs per dose. So I bring down here, I have dose in my equation here. So 193.3 milligrams per dose. But I need mils. So I have my denominator identifier, but I don't have my numerator identifier. So I need to eliminate milligrams and come up with mLs. Well, I have milligrams per mLs here. So I put the 250 milligrams on the bottom. That way I can cancel out the milligrams. And now I have my mils per dose. And then that comes out to where I will then draw up 0.77 mLs per dose from this 250 milligram per ml vial. I will pull out less than 1 ml, obviously, because I'm not. 193 tells me that it's less than this whole bottle. So that's another little check you can do for yourself. I've been supplied with 250, but I actually only need 193. So that tells me I will need to pull out less than what I was given. And this then tells me exactly I need to pull out 0.77 mLs per dose. Now, in order to do that, to be able to pull out that precise of a measurement of a dose, what syringe would I be using? Well, in this case, we know that 1 ml syringes have the most precise incremental lines on the syringe. And so at this case, I would use a 1 ml syringe to pull out this 0.77 mLs. At this point, I would then need to determine, based on your facility, will you be then just taking that ml syringe and plugging it into the syringe pump, or will you be taking that ml syringe and adding it to a little bit of volume in a larger syringe in order to put it to the syringe pump? But at this point, you are going to be the one that will determine, based on your facility, whether you give it directly out of this syringe or dilute it out with another syringe. And you will then, at that point, determine the rate of infusion. Thank you, Holly Forbish, for guiding me on this as she works with the pediatric and the infants. And she helped me make sure that I was correct in my math and correct in what I'm telling you here and gave me that guidance. So hope you enjoyed that video.